Have aliens visited us? This gripping question has sparked debate for decades. Could there be life beyond our blue planet, hidden within the vast mysteries of the cosmos? Stay tuned to delve into this captivating cosmic conundrum. The Drake equation, our mathematical approach to the likelihood of intelligent life in the universe. Now, imagine a cosmic calculator, crunching numbers to predict the existence of extraterrestrial civilizations. That's essentially what the Drake equation is. Devised by American astrophysicist Frank Drake in the early 1960s, this equation is our best mathematical guess to answer the question, are we alone in the universe? It breaks down the daunting task of estimating the number of civilizations we could potentially communicate with into manageable individual factors. The equation begins with the rate of star formation in our galaxy. Then it considers the fraction of those stars that have planetary systems. Next, it looks at the number of planets that could potentially support life as we know it. It then factors in the fraction of planets where life actually develops, the proportion of life that evolves into beings with the ability to communicate across interstellar distances, the lifespan of such civilizations, and so on. Now, the Drake equation isn't perfect. Many of its variables are based on educated guesses. We don't have exact numbers for these factors, and some are highly disputed among scientists. Yet, even with the most conservative estimates, the equation suggests that we are not alone. There could be thousands, if not millions, of civilizations out there waiting to be discovered. However, it's important to remember that the Drake equation only estimates the number of civilizations with whom we could potentially communicate. It doesn't guarantee their existence, nor does it mean they've paid us a visit. It's a tool that provides us with a framework for understanding the factors involved in the search for extraterrestrial intelligence. So, the math suggests it's possible, but what about the physical evidence? Unidentified flying objects. Are they evidence of extraterrestrial visits? The history of UFO sightings is as intriguing as the concept itself. This mystery dates back to ancient times when our ancestors looked up at the sky in awe and wonder. From ancient Roman reports of fiery shields dashing across the sky to modern-day sightings of strange lights and unexplained aerial phenomena, the narrative has been consistently fascinating. In the mid-20th century, sightings of unidentified flying objects increased dramatically, reaching a peak during the 1950s and 1960s. This was a time when the world was deep into the space race and the Cold War. People were curious, fearful, and imaginative. Many of these sightings were later explained as misinterpretations of natural phenomena like meteors, stars, or even the planet Venus. Others were the result of man-made objects like weather balloons, military aircraft, or even deliberate hoaxes. However, even after thorough investigations, a small percentage of these sightings remain unexplained. These are the cases that fuel our curiosity and imagination. They are the ones that make us wonder if we are indeed alone in the universe. In recent years, governments worldwide have started to take UFO sightings more seriously. Notably, in 2020, the United States Department of Defense declassified 3 videos of unidentified aerial phenomena, acknowledging that they could not explain the phenomena captured in these videos. This was a significant step, showing that governments are now willing to engage in open discussions about these unexplained sightings. While this acknowledgement does not confirm the existence of extraterrestrial life, it does give credibility to the subject. It encourages scientists, researchers, and the general public to look at these phenomena with an open mind, to question, to explore, and to seek answers. It's important to remember that unexplained doesn't automatically equate to extraterrestrial. There could be many reasons for these sightings that we are yet to discover. It could be unknown atmospheric phenomena, advanced human technology, or even a natural occurrence that we have yet to understand. Unexplained doesn't mean alien, but it does leave the door open to possibilities. Considering the vastness of time and space, could evolution have taken place elsewhere? A thought-provoking question indeed, and one that leads us to the concept of panspermia. Panspermia, a term coined in the 19th century, proposes that life exists throughout the universe, distributed by space dust, meteoroids, asteroids, comets, planetoids, and potentially spacecraft. It's a fascinating theory that suggests life on Earth may have originated from such cosmic travelers, carrying the seeds of life across the vast expanse of the cosmos. But how plausible is this idea, you might ask? Well, to answer that, let's consider the ingredients for life. The elements that make up the building blocks of life, carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur, these are not unique to our little blue planet. In fact, they are common throughout the universe. Carbon, the backbone of all known life, is the fourth most abundant element in the universe. Moreover, scientists have discovered complex organic molecules, the precursors to life, in interstellar clouds and on comets. They've found amino acids, the building blocks of proteins in meteorites, and they've even detected the potential biosignature of phosphine in the atmosphere of Venus. All these discoveries suggest that the universe is teeming with the ingredients necessary for life. Now let's talk about time. The universe is approximately 13.8 billion years old. Our solar system, a youthful 4.5 billion years. That's a whole lot of time for life to potentially arise elsewhere. So, given the ubiquity of life's ingredients throughout the cosmos and the vast timescales involved, it seems entirely plausible that life could have arisen elsewhere. Perhaps on planets orbiting distant stars, in the underground oceans of icy moons, or even in the clouds of gas giants. The possibilities are as countless as the stars in the night sky, and with each new scientific discovery, we inch closer to answering the question that has captivated humanity for centuries. Are we alone in the universe? The ingredients are out there, and the universe is vast and old. It seems likely that we're not alone. The Fermi Paradox. If there's a high probability of alien life, where is everybody? Well, let's dive into that. The Fermi Paradox, named after physicist Enrico Fermi, essentially asks, if there are a multitude of technologically advanced civilizations out there in the universe, why haven't we detected any signs of them? It's a compelling question that has puzzled scientists for decades. One possibility is that we may be looking in the wrong way. Think about it. We're using radio waves to try and detect alien life. But what if extraterrestrial civilizations are using a form of communication that's far beyond our comprehension, or even beyond our current technological capabilities? It's like trying to tune into a digital television broadcast using an old analog TV. You're simply not going to pick up the signal. Another suggestion is that we might be looking at the wrong time. The universe is approximately 13.8 billion years old. Human civilization, on the other hand, is just a blip in that timescale. It's entirely possible that alien civilizations rose and fell millions of years before we even existed. Or perhaps they'll come into being millions of years after we're gone. The timing might just be off. A more sobering explanation is the Great Filter theory. It proposes that at some point in the evolution of a civilization, there's an insurmountable hurdle or filter that wipes them out. If this is the case, it could mean that we're either one of the lucky few to have already passed this filter, or, more worryingly, the filter is still ahead of us. There are countless other hypotheses, each as intriguing as the last. We could be living in a cosmic zoo, watched over by alien civilizations that have chosen not to interfere, or perhaps the distances between stars are simply too vast for interstellar travel to be feasible. The universe is vast and mysterious, and we might just be starting to unravel its secrets. Remember, no one has the definitive answer to the Fermi Paradox. But isn't the search for those answers part of what makes our existence so fascinating? So, have aliens visited us? We've journeyed together through a cosmos of possibilities, piecing together a puzzle that spans the universe. We started with the Drake equation, our mathematical guidepost that hints at the potential number of civilizations in the Milky Way. Its variables, ranging from the rate of star formation to the likelihood of intelligent life, all point towards the possibility that we are not alone. We then delved into the myriad UFO sightings and government acknowledgments. These incidents, shrouded in mystery and intrigue, have fueled our collective curiosity and sparked countless debates. And while we can't conclusively say they're proof of extraterrestrial life, they certainly challenge our understanding of what's possible. We considered evolutionary possibilities next, exploring the idea that life as we know it might not be the only form out there. The universe is a vast, diverse canvas, and biology might just have more than one masterpiece up its sleeve. Might there be beings who perceive reality in ways we can't even fathom? It's a captivating thought. Lastly, we grappled with the Fermi Paradox, the contradiction between the high probability of extraterrestrial life and the lack of contact or evidence. It's a reminder of just how little we know and how much there is left to discover. So where does this leave us? We don't have definitive proof, but the universe is vast and we're still exploring. The question of whether aliens have visited us remains open, and our search for answers continues. We might not have them today or tomorrow, but every day brings us one step closer. Every star we chart, every signal we intercept, every theory we propose propels us forward. The question remains open, and the search continues.